Hi everybody, welcome back to chemistry. Today's video is going to be the first in our chapter 2 lecture series, which is all about chemistry and measurements. And this video is all about section 2.1, which is about the units of measurement. So what units do we use when we take measurements? So the goal for today is to be able to write the names and abbreviations for the metric and SI units used in measurements of volume, length, mass, temperature, and time. So if you look over here, you'll see there's always units that are written next to the measured values. And the reason for that is that it's very important to report what units you're measuring things in, because say you had a friend that was visiting from Canada where they use the metric system, and they were like, oh, it's 22 degrees outside, but they didn't specify Celsius or Fahrenheit. You might say, oh my gosh, like that's really cold, that's below freezing, because in Fahrenheit 22 degrees is below freezing, but it's much warmer in degrees Celsius. So it can make things really confusing if you're not showing your units. So really get in the habit of starting to show those, and you'll be in good shape. So for scientists, use the metric system. And even in the US, where we haven't quite adopted the metric system yet, we're still using the imperial system of measurement. Even scientists in the US use the metric system because it's just so much more convenient. So we'll talk about what the units of the metric system are. And then the international system of units is an official system of measurement that's used throughout the world for those units of, length, volume, mass, temperature, and time. And the reason that we have that official system is because we were running into problems when scientists were trying to communicate their findings around the world, and everybody's using different units, and it just gets all messy. So it really simplifies things to use the SI system. So here's a handy dandy table of the units used in the metric system versus the SI system. I'm not going to go over it too much, but I do want to highlight that this unit of measurement of volume, mass, and temperature are different. Okay, and we'll talk about what some of these on this side are, because they might be things you haven't seen before. We'll talk about this one as well. Okay, so for volume, volume is the amount of space a substance occupies, a measurement of the amount of space that a substance occupies. So in chemistry, or in the metric system in general, we measure using liters. So what a chemistry professor once told me that really stuck with me is that 1 liter is about the size of a Nalgene bottle. So if you filled your Nalgene water bottle up to the brim with water, oops, I forgot to put my 1 in there, 1 liter, then you would have a liter of water probably about. And then if you're looking at this meters cubed, the way I like to kind of visualize it is literally by drawing a cube that is filled with some liquid, let's just say water. And we wanted to know how much liquid was in there. Well, remember, we can measure the length of each side and determine using math how much liquid we have in there. So remember, meter times meter times meter is a meter cubed. So that's where that comes from. And then a lot of times in chemistry, we actually use mils. And that's because milliliters are a smaller unit of measurement than liters. And in chemistry, we're often measuring really small amounts. So 1,000 milliliters is in 1 liter. So liters are the larger unit of volume. Okay. And we'll work with graduated cylinders in lab a lot, which are used to measure small volumes. So stay tuned for that. All right, length. When we measure length for the metric and the SI system, it's a little easier because we just use meters for both. A meter is slightly longer than a yard. There's the actual conversion right here. Oh, sorry, I meant to highlight that. The actual conversion is right there. We'll be learning how to convert between these things in the future. Pretty soon here, actually. And then in chemistry, we probably aren't going to take very many measurements in meters, but we might take some in centimeters. So, and that's again because we're measuring smaller things in chemistry usually. For mass, the metric unit is grams and the SI unit is kilograms. So kilograms are larger than grams, right? There are 1,000 grams in 1 kilogram. So lots and lots of grams in a kilogram. So we know that kilograms are larger. And in some sciences, we actually use different, we'll use like, for instance, in chemistry, we measure lots of stuff in grams because we're, again, measuring small things, small amounts of substances, and you'll get really familiar with this electronic balance. That's how we'll measure lots of substances in chemistry. And then, but in physics, for instance, just as an example, they often measure things in kilograms. And the reason for that is that they're usually measuring larger objects in physics, right? Sometimes like as large as cars or stuff like that. So they don't want to be writing out, you know, something might be, this would be a large number to write out all the time in physics. Whereas in chemistry, we don't want to write like, we would rather measure in grams. And then for temperature, Celsius is what we use in the metric system, and then Kelvin, which you may not have heard of, is what we use in the SI system. So remember for degrees Celsius, we always want to write that degree sign in there. For Kelvin, we actually don't have it there, and that's because you don't write a degrees sign in Kelvin. It's just called the Kelvin scale. And so for the Kelvin scale, the temperature begins at the lowest possible temperature, which is 0 Kelvin. So notice I said 0 Kelvin and not 0 degrees Kelvin. Again, we just don't put that degree sign in there. So sometimes you'll even hear that referred to as absolute 0, and that just means 0 degrees Kelvin. You don't need to know that for this class, but it's just an interesting tidbit. And then water for the Celsius is freezes at 0. And then for Fahrenheit, it freezes at 32 degrees Fahrenheit. And then I also just want to add that water boils at 212 degrees Fahrenheit or 100 degrees Celsius. And that's why it's actually really a lot easier to use the Celsius measurement for temperature or unit for temperature because of those numbers are just a lot easier to work with. Time in seconds is a lot more intuitive for most folks. So we measure for SI and metric system, time is usually measured in seconds. Okay, so go ahead and pause the video and check your learning. What you want to do in this part is tell what the SI units are for the following. If you want to do a challenge, I would also try metric next. Okay, so pause the video, try that out. Okay, so let's see here. So for the SI unit for volume is cubic meter. What is it for metric? Yeah, liters. What about for mass? We've got kilograms for SI and what for metric? Grams. We've got meters for SI and also meters for metric, and Kelvin for SI and degrees Celsius for metric. Okay, and you'll notice that these two are capitalized and the other two are not. And that's just the convention. So don't put a lowercase c or a lowercase l. That would be, it would just look really funny. Okay. All right. That's it for this video. In the next video, we'll be talking about measured numbers and significant figures.